Here's everything you need to know about pi in 10 minutes. Pi. Pi is a very special number of the value 3.1415926535897933284627950288419716. Yeah, it keeps going, but what is it? Pi is an irrational number, which means it cannot be expressed as a ratio of two integers. It is also a transcendental number, which is essentially a number that cannot be a solution of a number involving only sums, products, powers, or integers. This brings rise to the problem of squaring the circle, which we'll talk about later. But we must address what pi actually is. Pi is the ratio of any circle's circumference to its diameter, which is expressed in the equation form as c over d. This means if someone can accurately measure the circumference and diameter of any random circle, it will produce pi when dividing the two numbers respectively. There are also some other important things to note with pi. Pi's decimals never end and are randomly distributed according to statistical significance. This gives the number its very random and non-uniform nature. Also, due to its transcendental nature, it is impossible to square the circle. This means that it is mathematically and physically impossible to construct a square with the exact same area of a given circle, using a straight edge and a compass alone. These properties are just the beginning of the uniqueness of pi, but we should go back to its origins to truly understand this magical number. Many years ago, Egyptians and Babylons experimented with the circumference and diameter of circles primarily for architecture and found that oftentimes a similar number was yielded when dividing one by the other. Although this number was often approximated as about 3, it was the first step in discovering the real value of pi. Later on, around 250 BC, a man by the name of Archimedes created the first approximation algorithm for pi, which utilized polygons and their perimeters. Essentially, Archimedes would inscribe and circumscribe a hexagon within a given circle and then double the sides while using Pythagorean principles to calculate its perimeters until there were 96 sides. This produced an upper and lower bound estimate of the circle's circumference, which was used to calculate pi as a number that lies between 223/71 and 22/7. This method, although unbeknownst to other parts of the world, would be used by other mathematicians to produce even more accurate approximations, using polygons with even more sides. Then, with a millennium's worth of time, these seemingly primitive calculations were replaced by those of infinite series. In short, infinite series are essentially a summation of an infinite amount of numbers in a certain way and order. The Gregor-Leibniz and Nilekantha series were some of the earlier infinite series used, with the Nilekantha series being generally more efficient than the other, but both still converging to a value of pi. The series start with a value of 4 and 3 respectively, but after just the fifth term of the Leibniz series, a value of 3.3396 is produced. A value of 3.1396 is produced after only 5 terms for the Nilekantha series, showing the narrowing accuracy of these infinite series to the value of pi. Other series were later created, utilizing arctan as shown, in which we will later see their prominence in modern calculations of pi. But it's important to note that the Greek letter pi was not used until 1706 by a Welsh mathematician named William Jones, a known friend of Isaac Newton. He was the first to use this letter as, by his definition, the quantity by which when you multiply by the diameter yields the circumference of a circle. Now in the modern world, it's almost comedic to go and compute pi by hand or through other archaic methods, with the growing prowess of calculus and immensely increasing computational power in our environment. The invention of calculus has allowed us to approximate hundreds of digits of pi, and new computational approaches have allowed us to approximate trillions of digits, leading us to the current 62.8 trillion known digits calculated in 2021. These computational approaches, fueled by mankind's drive to create efficient and effective algorithms to calculate numeric series and to break once conceivably impossible records, are now even used to test supercomputers. Iterative algorithms were some of the first modern algorithms to calculate pi, as they resulted in a no longer needed reliance on infinite series. Essentially, these types of algorithms repeat a specific calculation using outputs from prior steps as inputs, which all stem from an original guess. The most well-known is that of the Gauss-Legendre algorithm, which is known for its rapid convergence, with the first 25 iterations producing 45 million correct digits of pi. However, eventually rapidly convergent series would take over the iterative algorithms priorly used due to their equal efficiency and lower memory requirements. Their simplicity allowed for the avoidance of memory-intensive calculations and created many new series, like the few shown, but most notably the Chudnovsky formula, which has been used in many record attempts, including the current 62.8 trillion digit record, despite it being published all the way back in 1988. Other methods, while not being as efficient in the slightest degree, can still be used to complete the same task of calculating pi. The Monte Carlo methods rely on repeated random sampling and computational algorithms to calculate pi, An example of this method is taking a square and inscribing a quarter circle in it as such. Then dots are randomly placed countless times in the square quarter circle diagram. The ratio of dots placed inside the circle to the total number of dots is then calculated and should statistically be equal to pi over 4. Finally, spigot algorithms, essentially a type of algorithm used to calculate transcendental numbers like that of pi, can be used to compute single digits of pi. Although being much slower than newer algorithms, the ability to produce specific digits allows this method to be used to verify record claims of calculations of pi by checking digits that appear later on in certain computations. These many methods and algorithms are nice and all, but it is important to understand the mathematical and general uses of this number. First, there's the math side of things. Pi is used heavily in trigonometry calculations through the 6 trig functions and unit circles. It's also used heavily in calculations involving geometry due to its relation to circles, ellipses, and spheres. For example, when we rotate a function around an axis to find a volume, pi is also a ratio utilized to simplify the calculation. Pi is even used in number theory and statistics with the goal of finding newer and more efficient ways to calculate itself. Even outside of pure mathematics, pi is pretty useful. In the realm of the sciences, pi is found heavily in cosmology, fractals, thermodynamics, mechanics, and electromagnetism, and is necessary in producing meaningful outcomes in calculations. One interesting use in statistics relating to pi is that of the bell curve. Shown is the Gaussian function for a bell curve, which includes the factor of 1 over the square root of 2 pi. This factor allows the area under the graph to be equal to 1, which is necessary for a bell curve in a probability distribution. This factor is a result of computing the area of the base function of e to the negative u squared from negative infinity to positive infinity, which ends up equaling the square root of pi, and along with the change of variables, produces this special factor necessary for a large amount of statistics. Pi is also constantly found within many aspects of architecture. Specifically with pyramids, pi has been found in the creation whether intentionally or not. The Great Pyramid of Khufu, which is Giza, was measured, and it has been discovered that the height of the pyramid roughly equals the radius of the circle that has a circumference equal to the perimeter of the pyramids. When using this information to calculate pi, a ratio of 3.1419 is found, which is only 0.03% off of pi. Although this pi theory is often met with skepticism, it is interesting to note how pi may have been used, whether consciously or not, in constructing very symmetrical and complex pyramids. There's a large culture that is built off this beautiful value of pi as well. Humans have used it as a method of competition, seeing who can memorize the most digits and recite them accurately. As of 2022, Rajveer Meena was able to memorize and recite 70,000 post-decimal digits of pi, claiming the current world record. Then, there's Pi Day, which mathematicians and professors gawk over everywhere every year. Celebrated on March 14th unofficially, it is a day that many famous people have relations to. Einstein was born on Pi Day, and Stephen Hawking died on it. There's even a Tau Day, which is celebrated on June 28th, due to Tau being unofficially used as 2 pi. While Tau is not officially 2 pi, it is widely used as 2 pi and has even been added as math.tau in Python, a coding language. Even in literature, pi is found. There is a style of writing often referred to as Pilish, in which full books have been written to. Pilish is essentially a style of writing in which each word has a length that corresponds to the digits of pi, and an order too. For example, the first book written completely in Pilish was by a software engineer, Michael Keith, and called Not Awake, which consisted of around 10,000 words. The first lines of the book go as such. Now I fall, a tired suburban in liquid under the trees, drifting alongside forests simmering red in the twilight over Europe. Notice how the length of each word in order is the value of pi. Neat, right? In the end, pi is so complex that we will never know all of its digits, primarily because it goes on forever. However, our approximation is so accurate that if you round pi to the nearest 9 decimal places, you can calculate the Earth's circumference with it only differing by 1/4 of an inch every 25,000 miles. Our deep understanding of pi is growing every day, and soon maybe we will discover more wonders about this magical number. But until then, this has been everything you need to know about pi in 10 minutes.